Welcome to Module 4, Topic 1, Lesson 3. Do me a solid. Building three-dimensional figures. Alright, warm up. We should have already done, but in the event that we did not, here it is. You can see that all these horizontal lines are 13. Same thing for this. And when we compare the area of both the rectangle and parallelogram, we get 78 for both. Make sure to keep an eye out for key terms and fill out your vocabulary. All right, getting started. So an office building has a revolving door at the entrance. The door has congruent rectangular door panels that rotate around the center pole. Rectangle ABCD represents one of the door panels. All right, so consider point A. Describe the shape the point traces as the door panels rotate around the center. So as A is rotating, it's creating a circle on the floor. Consider side AB. If that rotates, what shape will it create? Well, AB is dragging along the floor, so if it drags all the way around, it should create a filled-in circle, which is called a disk. Consider all the points that make up rectangle ABCD. What solid seems to be formed as the door panel rotates around? So as this whole door is rotating around, it should create a three-dimensional shape. So a cylinder would be formed as the rectangular door rotates. A disk is formed on the top, a disk is formed at the bottom, and then all the points in between should be filled in. So it should create a cylinder. All right, activity 3.1, rotating two-dimensional shapes through space. Previously, you learned about rotations on a coordinate plane. You can also perform rotations in three-dimensional space. For each question in 1 through 3, draw the shape on the index card. Draw out the shape and tape it along the center to a pencil and hold on the eraser with your thumb and index finger and then rotate the shape. Okay, we're not going to take this time to do that part. Instead, I'm going to show you a video example. All right, sketch the three-dimensional solid. So sketch the three-dimensional solid form by spinning the two-dimensional shape. So rectangle. Alright, so you can sketch a cylinder by sketching two ovals that are stacked one directly on top of over the other, and then just connect the sides of those ovals with line segments. Relate the dimensions of the rectangle to the dimensions of the solid. Well, we know that the height of the rectangle should equal the height of the cylinder, and that the width, or whatever you want to call this, the horizontal measurement here, should be the same as the diameter of the cylinder. All right, so a disc. We're gonna rotate this circle.
What's up, my gang? Welcome to Hood. Hood and chill. Kara table wonder dude. Make a gang send their and is real chill baju. Jab young watch the hood will be all on the mood. What's up, my gang?
As you can see, rotating a circle should create a sphere. You can draw a sphere by drawing a circle and then drawing an oval that goes through the middle of it like that. Name the solid formed by rotating the disc around the pencil. We call that a sphere, which is just a ball. All right, rotate the dimensions, relate the dimensions. So the diameter of the circle should equal the diameter of the sphere. Same thing for radius. All right, now we're going to do a triangle.
Do TBT, das bucetas de mel. Hoje você fode com a tropa da Chucavel.
Dime lo que quieres.
Tropa da Chuca, fode com a tropa da
Dime lo que quieres.
Tropa da Chuca, fode com a tropa da
Dime lo que quieres.
As you can see, it's a cone. You can draw a cone by drawing an oval, drawing a point above the middle of that oval and connecting that point to either side of the oval. B, name the solid formed by rotating that triangle, that's a cone. Relate the dimensions of the triangle to the dimensions of the cone. So the height of the triangle equals the height of the cone. The base of the triangle equals the diameter of the cone. All right, the math club at a school is planning a pancake breakfast as a fundraiser. Because this is a fundraiser for the math club, the pancakes will use various geometric shapes. Imagine you stack each of the geometric pancakes on top of each other. Name the solid formed by each stack of pancakes and relate the dimensions of each pancake to the dimensions of the solid figure created. So as you can see here, if I take circular pancakes and I stack them like this, it's going to create a cylindrical shape. So just see here, it just creates a cylinder. The diameter or radius of the pancake will be the same, the diameter or radius of the cylinder. All right, now if we have a square pancake, like this, then it's going to create a rectangular prism, or a square prism if you prefer. But it didn't specify that this was a square, so I just went with rectangular prism. Anyway, the length and width of the pancake should be the same thing as the length and width of the prism. Last but not least, we got a triangular shape. When we stack that up, we can see here that all three of those vertices for each stacked triangle is going to come together to create a triangular prism. The base of the pancake versus the altitude, it would be the same thing here, the base versus the altitude. All right, so what do you notice about three-dimensional solids created by stacking congruent figures? Well, they create prisms. What type of solid would be formed by stacking congruent rectangles, pentagons, or hexagons? Well, if you stack rectangles, that'd be rectangular prisms. If you stack pentagons, that'd be pentagonal prisms, and hexagons would form a hexagonal prism.